Hello, my name is Ignacio and welcome to this video on harmonic series. In this video we'll learn what harmonic series are. We will see the sum of all the terms of an harmonic series converges and diverges, and we will solve a problem on harmonic series. So, we have here in the screen the harmonic series. It starts with 1, then goes 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on. So the first thing we have to guess is, what is the nth term of an harmonic series? And yes, the nth term of an harmonic series will be 1 over n. So for example, the 50th term will be 1 over 50. So now we are going to guess if the harmonic series will diverge or converge. So this represents the sum of all the terms in our harmonic series. Starts with the first and it goes until 1 over n. So in order to guess if it diverges or converges, we are going to compare our harmonic series with other series. So this is our harmonic series, and this is our other series. I want you to know that there are some terms that are changed. So for example, we have changed 1 over 3 in the harmonic series by 1 over 4, and 1 over 5, 1 over 6, and 1 over 7 in the harmonic series by 1 over 8 in here. So I want you to know that all the terms in here are smaller than the terms that were in here. So it's very important to know if this harmonic series is bigger or smaller than this series. Well, it's actually bigger. Our harmonic series is bigger than the other series. So now I want to keep developing this idea, and what we're going to make is to know if this one diverges or converges. And if it results that this one diverges, as this one is bigger, the harmonic series is bigger, we'll know that the harmonic series also diverges. So we are going to start adding terms in our second series. So we have the first one is 1, the second will be 1 over 2, and now we're going to start adding in groups. So both 1 over 4 will add up to 1 over 2, and all the 1/8 will add up to 1 over 2. The next terms will be 1 over 16, and they would also add up to 1 over 2, and so on and so on. So we can know that this series diverges. So our harmonic series will diverge or will not diverge. Well, it will diverge. So now that we know that our harmonic series diverges, we are going to see a problem, which is called the worm paradox. We're actually going to make it with an ant, but it's the same idea. So suppose that an ant crawls along a 1 meter rubber band at the same time as the rubber band is uniformly stretched. The ant travels 1 centimeter per minute, and the band stretches 1 meter per minute. Will the ant ever reach the end of the rubber band? So I know this is a complicated problem to understand, so I have made a few drawings in order to explain them. So we have at the beginning of the problem our ant, which is this smiley face, and our rubber band, that is the 1 meter line. So at the beginning the ant is in the position 0, and it will start crawling. So it will crawl 1 centimeter, and then 1 times equal 2, it will walk another centimeter, but the problem is that the ground will stretch by 1 meter. And the same will happen 1 time equals 3. So it is asking if at any time the ant will reach the end. And it looks like it won't, as every centimeter the ant walks, the rope stretches more and more. However, this paradox, the solution of this problem is that it works, and we are going to demonstrate it thanks to the harmonic series. So what we are going to make is to first guess the radio of what the ant walked in each step. So I have converted here the length to centimeters so it's easier and all the numbers are in the same unit. So we are going to guess first what it walked at time equals 1. And yes, it's 1 over 100 centimeters, the radius of the distance that it advanced over the total distance. What will be at time equals 2? It will be 1 over 200. It still advances 1 centimeter, but now the rope is 200. And at time equals 3. 1 over 300, right? So the total distance that we walk will be the sum of all the radius of distance. So it will be 1 over 100 plus 1 over 200 plus 1 over 300 and so on. So now we have to transform this into our harmonic series and try to solve the problem. So here we have it, and we're going to start by taking common factor. We can take the common factor of 100, and it will be something like this. Can you see the harmonic series in this operation in here? Well, I want you to notice that it is in there. It is that part of the parenthesis, it's our harmonic series, which is, as is represented in the right, is the sum of all the terms from n equals 1 until k of 1 over n. So it will start when n equals 1, 1, when n equals 2, 1 over 2, when n equals 3, 1 over 3, and will continue forever. So this will be the same as this. We are just substituting our parentheses by the harmonic series. And then we can pass multiplying the 1 over 100, so it will be that 100d will be equal to our harmonic series. So the question is, will the n ever reach the n? In other words, will the harmonic series be equal to 100d? And the answer is yes, it would, as we know that harmonic series diverge. So as they diverge, they will always reach the point we are looking to. The end will actually take a lot of time to reach the end, but the answer to the problem is yes, the end will reach the end of the ground. So we have solved a very complicated problem, which is called the end paradox problem. And now, before ending this video, I wanted to show you some harmonic series in nature. So if we look at one rope creating a wave, the frequency of that wave goes following the harmonic series. So it's 1, 1 over 2, 1 over 3, 1 over 4, and so on and so on. And this creates different sounds, known also as the pentatonic scale, which is the one we are seeing in the right. C, D, E, G, A, C, and it goes on forever. These 5 different sounds form lots of songs, such as the Amazing Grace we are hearing in the background, and Chinese popular songs, gospel, blues, African American songs, Latin American songs, Scottish songs. A lot of songs are based in this harmonic series because it's part of nature. So as you keep hearing harmonic series, I want you to see the citations, and well, I hope you have liked the video and that you have learned something new.